wish you that I hope everyone is well. And can I also put on record thanks to the staff of the NATO PA for their work in organising this and the other sessions. I accept that we perhaps have some technical problems at the moment with some participants, but I understand they will join us later. But can I begin by introducing our speaker today, Dr. Kamalides, who is the principal on Space Department at the Johns Hopkins University and chairs the Science of Space at the Academy of Athens, an advisor to the Minister of Digital Governance of the Hellenic Republic. His CV, I understand, is in our documentation, but can I give him a warm welcome, who he will now address us on space insecurity and the economy. The floor is now yours, Dr. Kamalides. Oh, he needs to. Sorry, you need to unmute. We can't hear you.
Yes. Thank you very much, Mr. Chairman, for the invitation. This is the first time that I address the Parliamentary Committee of NATO. When I was young, I participated many times in NATO-sponsored workshops as a scientist, of course. And this is the one time when I would not wear my scientific hat, but rather that one of the manager of programs for NASA and participant in programs in the European Space Agency. So I'd like to ask that we saw the slides that I have prepared. I hope this is successful. Is that possible? What happened to the gentleman who was going to show the slides for me?
Stefan, is that you or?
No, it's not me. It's somebody from the audio video team, but he's actually now coming on, so he will take care of it.
Oh, great.
Here we go.
What you see there is just my opening slide and the title, one of the things that I want to point out in a kind of a high level view was the global space economy. As you can see in the center, the number is 360 billion per year. These are numbers from 2018. They're likely higher in 2019, perhaps not this year. But I would like to point out I know you cannot see a cursor, but to the upper left, you see the expenditures by the various governments. And you can just see that the numbers for the United States is about 50 billion per year, and that includes both NASA, which is in the upper left of the pie, and it's about $20 billion, 18 for this past year, but it is 20 billion today. And then the remainder is the various agencies of the Department of Defense. So the total for the United States is about 50 billion per year. The total for the rest of the world is about 31 billion, out of which 11.5 is Europe, and 8.5 or 9 is China, and then the rest are India, Japan, the rest of the world, and Russia. So the key point to recognize from this particular chart is the fact that only about 22% or so is government expenditures. The rest of the pie consists of commercial satellite services and equipment, TV, radio, internet, Earth observations, satellite manufacturing, and so on and so forth. This amount is not insignificant. It's about the same as the GDP of Norway, for example. If we can go to the next slide, I'd like to point out that I don't see it yet, but I hope you see it soon. Next slide, please. Next one. It compares the rate of growth of the economy in space versus, it doesn't seem to advance. Can you put up the next slide, please? I was afraid of that. Perhaps you can sort of reopen it and then start clicking through. Yeah, you see the next, that's the one.
Sorry, there's a slide that doesn't appear. No.
No, I saw it in the summary in the.
Yes, but when. Okay.
Okay, here it is. Yeah, I see it. It glanced by me.
It disappears
there
every
it
time.
Is. Oh.
Every time I'm going on it, it disappears. Sorry.
Okay. Well, what that particular slide points out is that the rate of growth in space expenditures is about twice that of the economy as a whole. And you can imagine that this is a growing area, provides both jobs and services, and will continue to do so for the foreseeable future. Now you might say, what is it that we're getting out of space? And I want to point out in this slide that most people think we have all kinds of things in the air, and we do. However, the ground is actually a lot bigger. And if you click, what you will see is that we produce lots of data. And the data, of course, have to be transformed into real information. And that's where a lot of the action is. And if you click again, the data starts from the institutions, the government, the universities, the research centers, and then it has now translated itself mostly into the commercial sector. In the next slide, what you will see is the investments of the European Union. And the most prominent one in the upper right is the Galileo program that we all know and love, that has consumed about 22 billion since it started in 1998. And it's providing location for any person that wishes to know where they are on the surface of Earth, in case they don't. And the next biggest, sorry, not yet. The next biggest element is Copernicus. Now, that may not be a word that you recognize as a program area. I know you recognize Copernicus, but it is essentially the European contribution to the information treasure for global warming. It's data that is collected from all over the world, and it has, since its inception, it's cost about 6.7 billion and growing. And in the following slide, I will show that what ESA, the European Space Agency, does in terms of programs and contributions. Next slide, please. Now, this is from ESA Space 19+, which took place in Seville last year. And it's the council at the ministerial level that takes place every 3 years and asks for contributions from member states 2 voluntary programs. And if you click again, I bet if you squint, you'll see a white head there. That's myself. And this is the 4 pillars that ESA's program rests on is science and exploration, safety and security, applications, and enabling support. In its area, there are several sub-areas. In safety and security, for example, has to do with space objects, but it also has to do with a new threat that most people don't really recognize, and that is space weather. Just like we have weather on Earth, meteorological weather, we also have space weather because occasionally the sun explodes and sends a big cloud of radiation into space that can affect our communication satellites, our weather satellites, our observing satellites for the surface of the Earth, and a whole lot of infrastructure, including high-power transmission lines for electricity from the generators in several places to the cities and towns of the entire world. So these are some of the activities that are involved in safety and security. Give you an example of what actually Copernicus measures in this case is the next slide, please. What you see is the temperature of the surface of the Earth for June of 2019. And the precision with which this can be done is something to the level of about 1/10 of a degree centigrade. And this is the kinds of information that is needed to follow over time the evolution of temperature over the entire sphere and what exactly contributes to global warming. The next slide, that will show you again what Copernicus does, is another image on the top right. You see a picture of the globe, flattened, of course, and you can see all these red points, for example, in South America, in South Africa. What that you see there is formaldehyde, which is a byproduct of burning of vegetation and forests. And on top is August of 2019. On the bottom is August of 2018 is at the top. On the bottom, August of 2019. And you can see, for example, the intensification of the fire in South America, in the Amazon region. And you can even see the fires in Siberia over to the upper right of that image. So it's a very sensitive way to assess what happens throughout the world, not unfortunately in a real-time basis, but close to that. So it's really a big tool in understanding our environment and where our world is going. So if I can just show in the next slide where things are headed. Space is going through a transformation. We have artificial intelligence, we have big data, and we have signal intelligence, reconnaissance from multiple sources. And of course, we have to analyze all that. And then we have position, navigation, and timing, precise geolocation, and spoofing technology, which has a lot to do with the activities in the military arena. The next shows the satellite communications from this acronym you see, LEO, means low Earth orbit, because a lot of the satellite communications come from distances about 35,000 kilometers from the surface of the Earth. Now, however, there are constellations that are being launched thousands of satellites in low Earth orbit, meaning between 500 and 800 kilometers altitude. And I will say in a few minutes how important that is. The next one is the small satellite revolution. What used to take hundreds of kilograms to do, it now takes us a few tens of kilograms at most. The next one has to do with the responsive launchers. When one plans to launch a mission into space, it usually takes months to prepare the launcher, to prepare the spacecraft, to put them on top of each other, and then to launch it into space. What now is happening is that these things have moved from years and months to days and weeks. And the next area is, of course, the new space, the private investment where all the action is. I'm sure there is no person in the world that hasn't heard of Elon Musk or Jeff Bezos and other startups. And it's really a game-changing applications in both the launchers. We know that, for example, the latest SpaceX, Elon Musk's launcher to the space station, and applications with satellites. And so this is where space is going. And in the next slide, I wanted to point out what is happening in lower orbit. You see here a diagram that shows two satellites, and the red line between them is actually optical communication. What does that mean, optical communication? It means that we are going to be going from the megabits per second to gigabits per second. 10 times more data, 10 times higher speeds. And that's going to be possible by doing optical communications from low altitude and transmitting the data to the ground. This is a roadmap that NASA had shown, but there are similar activities in ESA and other parts of the world about the next revolution, which is going to be optical communications, and we're going to move from the tens of megabits to tens of gigabits. In the next slide, I am showing you what is possible with these small spacecraft and the startup companies like EarthEye and Planet. EarthEye is in the UK, Planet is in the United States. And what you see there is the Dubai airport and a Airbus 388 in flight that has taken off, and from the general direction and using artificial intelligence, one can tell that this particular aircraft is going to be going to Johannesburg, South Africa. This is from information that's already in existence, and it's stored, and the history tells the operator of the spacecraft and the databases of where this satellite is going. So you might say, where are we headed with this kind of very detailed information? If you click, I will tell you, some of you are familiar with Google Earth. Well, that, of course, describes every point on the surface of the Earth in fair amount of detail. What we're moving to is near real-time Google Earth. In other words, the possibility that one wants, let's say, to look at Brussels in real time and dials it in, and sure enough, there is data there, and it shows you a movie of what is happening in Brussels in real time. This is the direction that the world is headed. Beyond that, in the next slide, I thought I would show you this autonomous and reconfigurable swarms of spacecraft and sensors that includes not only satellites, but drones and aircraft, where the resolution is so good that you can now do perimeter security in a plant or an airport or wherever, and essentially direct guards to go to the right place. This is actually a funded project. It's called Euroswarm, that is funded by the European Defense Agency, and there are several universities that are participating in that, including one in Patras in Greece. So if I could go on to my last, to the next slide, one before last, with small spacecraft, the so-called Cubesats, it's going to be possible to monitor persistently points on the surface of the Earth with high revisit time. In other words, you can have data and information near real time. And we can think of all kinds of applications, including, of course, refugee flows for one thing, and many, many other things. And so the future is really very promising in terms of applications of space in both the economy and the military. And the next slide, I wanted to show you the one on the left is a rack that contains a number of Cubesats. Cubesats, as I pointed out, is the small spacecraft. And this is a rack on Planet company in the United States that has all these spacecraft ready to go. And within a few days, they can put one on a launcher and send it to replace one that failed in orbit, for example. And on the right, you see another startup company, this one in Germany, that is experimenting with a launcher that is going to decrease the cost of putting a spacecraft in low Earth orbit by as much as 75% to 80%. So it's a different ball game, and it's all enabled by our ability to get in space and look down. And I'd like to conclude by the next slide, where we see that space is actually transforming the defense sector. If you click once more, next, and I have to be able to read it here. And so continued investment is needed for geolocation. And we have the American GPS, of course, that is well known to everyone in the world, but we also have Galileo. And that gives us persistent monitoring from space with small satellites and advanced communication systems. And we have all heard about G5, and we are fighting about that. But it won't be long before we all hear and start arguing about G6, which is 10 times faster and maybe 100 times faster. And of course, the era of quantum computing is not far away, which will increase the computing capability tremendously. So in terms of NATO, as you know, the United States has the Defense Advanced Research Projects Agency, DARPA. But it's my sense that NATO really needs more than one DARPA, especially in Europe. These agencies bring game-changing technologies to operation in short turnaround times and is linked to capability needs. And it is a tool, I believe, that NATO needs, and not just in the United States, but also in Europe as well. And finally, the need to develop closer links between space defense in a NATO integrated manner, which does not now exist. So this is, in short, the best I could do in the time available. I would like to thank you very much for your attention, and I would be pleased to respond to any questions anyone may have. Thank you. That's the end of the slides.
Right. Thank you very much for that, Dr. Kamiz. Can I now ask Marita, the head of the Greek delegation, who had some technical problems early on, to speak? I understand now we've got a problem.
Πριν είχε
Can I
κάποια
hand the
τεχνικά
floor to Greece? And then I'll open
προβλήματα
up for questions.
σύνδεσης, να λάβει το λόγο.
Thank you.
Σας ευχαριστώ πολύ.
Economics and Security Committee, dear colleagues, it is a great pleasure that we have today the head emeritus of the Space Department Applied Physics Laboratory at Johns Hopkins University and chairman of the National Committee for Space Research in the Academy of Athens, Mr. Stamatios Krimizis. Mr. Krimizis is one of those special cases of successful Greeks living abroad who worked at agencies, organizations, and private companies, in this case NASA, and his achievement received international recognition. I could not think for a better person to join our online meeting today. Professor, thank you. Thank you that you are today with us.
Ευχαριστώ θερμά που βρίσκεστε μαζί μας σήμερα.
It is my pleasure.
Είναι ευχαρίστησή μου, κύριε Γιαννάκου.
It's a privilege and I thank you very much for
αποτελεί προνόμιο
inviting me
και σας ευχαριστώ πολύ.
Chairman of the two committees for the
Ευχαριστώ και τους προέδρους των δύο υποεπιτροπών,
the parliamentary meeting of NATO.
Για την πρόσκληση στην διακοινοβουλευτική σύνοδο του ΝΑΤΟ.
It's very unfortunate that we had this technical problem in the beginning and we didn't have you at the outset of the presentation.
Είναι ατυχές το ότι είχαμε αυτό το τεχνικό πρόβλημα στην αρχή και δεν μπορέσαμε να σας ακούσουμε.
So, thank you very much.
Σας ευχαριστώ λοιπόν για άλλη μια φορά.
And again, I will be happy to answer any questions anyone may have.
Και πάλι είμαι στη διάθεσή σας αν υπάρχουν ερωτήσεις.
Can I thank you for that? Can I now open the meeting to questions for Dr. Krimizis?
Yes, we have Ivans Clementievs who has requested to speak.
And how do we do this?
Somebody will actually he has requested and he's now on.
Right.
Thank you, Mr. Krimizis. It's very interesting topic about the space, because the space in the future, and also my second committee is Science and Technology Committee, what was very interesting, and to visit some NASA space centers in California. It was very interesting. Latvia also becomes a member of European Space Center this year. We launched just very small satellite, just 1 kilograms weight, but it's also a success for us. But we have very big locator in the Latvia, what our scientists also can working with this. And how you see in the future this space rocket, what we launched, United States launched just a few months ago, how quickly it will be development, and maybe after a few years, that many tourists can to visit some planet. Thank you very much.
I assume, thank you very much, Mr. Krimizis. I assume you are talking about the SLS, the Space Launch System, which is the rocket that will take astronauts to the moon, presumably in 2024. There's some question about that, whether it will be that soon, but eventually it will be so. It's a very large and expensive rocket. It will do indeed the trips to the moon, and I'm pretty sure it's going to be exceptionally successful in that. However, in terms of projections to Mars, I think that is an issue that it's much more in the future, because such a program is going to be exceptionally expensive. It has been estimated that's going to be between 500 billion and $1 trillion, or euros, whichever. In either case, it doesn't make any difference at that level. So the governments, I think, are going to cooperate on that, and it's going to be probably a world project. It will not necessarily be just a NASA project. And I suspect that there will be representatives in the crew that will go to Mars, probably from many countries in the world, including Europeans and maybe Latvians, who knows, or even Greeks. That, I suspect, is not likely to take place until the late 30s or even later, because it's an expensive proposition, and I don't think a single country is going to commit to that.
Thank you very much.
Who have we got next, Stefan?
At this point, we do not have another speaking request.
Maybe can I say closing remark, Kevin?
No, actually, we have one now. Mr.
All right.
Philippe Michel Klespala.
Philippe? You look like you're in the dark,
Merci, très cher président.
Thank you very much. Thank you, Ivans, and thank you, Stamatis Koumigas. It's an honor to listen to you, and your experience is very telling. So there is a wider access to space technologies, and there are more and more space actors, including private ones. And this means also there's an increase of threats in spaces. Spatial politics is meant to play a bigger and bigger role in this transition towards a sustainable world. It will bring about solutions to societal challenges, and it will preserve the functioning of natural ecosystems for the good of future generations, as you said. Therefore, spatial stakes are crucial for our sovereignty and resilience. And our country has understood it. In 2017, it created a Center for Spatial Applications. Back then, the announcement was not necessarily well understood because of the economic situation. However, it was of crucial importance. This agency serves the citizens, and it should favor the use of systems to localize fires, but also for civil protection and political protection. Therefore, my first question is the following. In Greece today, how important is the spatial domain seen in terms of economy and security? Secondly, space is important, especially in terms of cyber security and our daily life as well. It plays an important role for military operations. It gives them autonomy and autonomous decision-making power, but it's also a major asset in the face of our strategic competitors. In this widened environment to more domains, it's more and more being contested. In space, our satellites are sometimes jammed and spied on. There are ways to destroy spatial capabilities of our adversaries, and France, with the US, shares the analysis of the threats and the growing threats in the space environment. This is why we are trying to find common answers with our allies. And in this matter, France has actually a strategy and a doctrine. And this leads me to my second question. How do you see the state of ownership of this spatial issue and the stakes within our allies? And finally, NATO's operational superiority depends on our technical sovereignty. And this is why France wants to strengthen its cooperation with key partners, with the US notably. And it wishes, for instance, to train people. And this is part of what we are looking at. We need to have our own way of dealing with this in Europe, and we must not solely depend on actors outside of Europe. Therefore, according to you, how can in Europe we can stimulate innovation and strengthen an integrated approach in all of the spatial logistic chain? Thank you.
Thank you for the question. I hope I can remember all elements of it. The first one was about the Greek space activities, and it is true that Greece got a late start in addressing space capabilities, and is now developing a small industrial base with help, I must say, from other European countries, including France and Germany, who are going to assist in many ways, including the possibility that Greece could become a place for assembly of small satellites and use thereof. So the nascent space organization of Greece, the Hellenic Space Center, is now organizing to see to what extent not only utilize the Copernicus and other elements of the ESA program, but also how, in collaboration with other European countries within the ESA context, can develop some small satellites that would both enhance the technical capabilities and also serve its own national needs. So Greece has some ways to go, but eventually we'll get there because there are a lot of good, well-trained people that can really pick it up and go fairly quickly. In terms of the of military space, needless to say, we all know the investments that France has made and the progress that they have made and the significance that they attach to military space. I can't speak for the United States except to offer my perception and a sense that probably from next year on, the willingness and policy of the United States is likely to be much closer to the thinking of the Europe and European Space Agency and CNES, the French Space Agency, about how to best utilize space for security and in the military sense as well. We all know that the United States went ahead and established the so-called Space Command. My sense is that that will, of course, move forward, but I think it's going to be much more integrated with NATO than heretofore when it was established. You pointed out that, of course, that would stimulate also innovation in Europe, and that was precisely the point that I was trying to make about the need for a DARPA of Europe. That would be a joint enterprise among European Union states that would really contribute and push the innovation and technology frontier much more than it has been possible so far. I hope I did cover your main points. If not, please let me know. Thank you.
Thank you, Dr. Kamiz. Stefan, have we got any other questions?
No, we do not have.
Can I take the chairman's privilege then and ask a question, Dr. Kamiz? You raised the issue around the proliferation of satellites from private companies and nation states. Space is clearly going to become a very busy place, and I just wonder what your thoughts are on not only in terms of legal rules around who uses space, but also the issue of, I think the Americans call it space trash, that you're going to have a lot of satellites or small objects in space, risk of collision, but also how we possibly recover satellites or make sure that they re-enter safely. I'd just like to think what your thoughts are on that.
That's a very good and very key question. In fact, I know that in the recent past, the UK has undertaken a program to see to what extent it is possible to deorbit some of the space trash that's already in orbit. And there are tens of thousands of objects that are there that pose a risk not just to the International Space Station, but also to all kinds of spacecraft that are in Earth orbit. And I think the difficulty is that there hasn't been a common strategy that developed from all the countries of the world, all the spacefaring nations of the world, on how to do this in a collective way. And I hope that in the next year, if there is what we all hope will be some policy changes in the United States vis-a-vis the collective approach to these international problems, because it does not help any of the countries involved, whether a foe or friend, to have a situation where their assets are continually under threat because of space debris. So it's a very important problem, and I think, or I hope, that in the next few years we're going to have a collective approach, and hopefully the United States will take the lead in that direction.
Could you just address the issue around who uses space in terms of legal agreements around different orbits? Because that's obviously going to be an issue in terms of if you've got increasing number of private satellites, for example.
Well, that's another excellent point. You know, I was, as you all know, the Starlink program communication system that Elon Musk is putting up probably already has something like 700 spacecraft in low Earth orbit. And I have seen news reports that he aspires to be to have as many as tens of thousands. and his company is not the only one. There are others that aspire to do similar things, because the internet in the sky, I think, is what they're trying to establish, that will essentially make the fiber optic networks obsolete in a not too distant future. So who controls that? I frankly don't know. They get permission from the United States Department of Commerce on putting up these small satellites. But as far as I know, there is no international agreement on who goes where and how. The principal practice is, of course, that a lot of the rocket ships that take up the satellites are required to re-enter the atmosphere and burn up. And that is the principal requirement of the Department of Commerce in the United States. But the spacecraft themselves, there is no requirement on when they have to come down. Although I understand that in the Starlink project of Elon Musk's, they have reserved some fuel to direct the spacecraft to deorbit if there is danger of any kind of a collision. That's about all I know, and it's another area where, as you alluded to, we are in dire need of international regulation of some kind.
Thank you, Dr. Stefan, do we have any more questions? Or?
No, we do not have any more questions. Right. I think Ivans will conclude this meeting, and then he will announce how we continue.
Yes.
Right.
Could I hand over
to Ivan?
Thank you, Kevin. Thank you, Stefan. Dr. Kremigis, on behalf of both committees, thank you very much for your excellent presentation. Thanks to all members for their constructive and fruitful participation during our meeting today. And I would like to express our gratitude to the Greek delegation for organizing this meeting. I would also like to thank our interpreters who have done a magnificent job in allowing us to communicate so effectively. Members of the Economic Security Committee meeting will continue tomorrow at 3 p.m. Have a nice evening and see you tomorrow. Members of Science and Technology Committee, your meeting will continue at 17:15, so after 7 minutes. Please note that you will need to move to another virtual room. You should have the link, but NATO PA staff will post it again in the chat box on the right-hand side of your screen. After 7 minutes, please return back. Thank you very much.
Thank you very much for the invitation.
Thank you.